What's up guys, it's the Bio Chef here. Today I'm going to be talking about selective permeability. So I'm going to use a real life example to explain the concept of selective permeability. So imagine it's a Friday night and you're chilling with your friends. So you guys decide to go clubbing. So when you get to a club, you usually have to go through the entrance, of course, unless you're like VIP. But at the entrance, there will be someone there. This person is usually called the bouncer. The bouncer is in charge of who goes and who does not go into the club. If someone's pulling up to the club looking like this, I don't think any explanation is needed. He is not getting in. The bouncer's going to take one look at him and tell him, get out of here. But if someone like this pulls up to the club looking all snazzy, dripped down Gucci, the bouncer's going to be like, oh yeah man, you good. Selective permeability is just like the bouncer because it decides what goes in and comes out of the cell. This picture shows a cell membrane bouncer letting a nutrient in. An example of a nutrient that's let in is glucose. Glucose enters the cell and is used as a source of energy. Some ions, such as potassium and sodium, can pass through specialized proteins in the cell membrane. Nonpolar molecules such as carbon dioxide can diffuse easily through the lipid bilayer of a cell membrane. Water can also freely pass through the cell membrane, helping to regulate the cell's hydration levels. Last but not least, oxygen is essential for the survival of many cells, and the cell membrane allows it to diffuse into the cell. So here's a diagram of the phospholipid bilayer, and I'm going to talk about some features of the membrane that confer selective permeability. The lipid bilayer structure is composed of a double layer of phospholipid molecules, which act as a barrier to many ions and polar molecules. This molecule right here is cholesterol, and this is usually found in animal cell membranes, and it helps to regulate fluidity, preventing the membrane from becoming too fluid or too rigid. And right here is a channel protein, also known as an integral protein. And these are proteins embedded in the lipid bilayer that act as a channel or pump to regulate the movement of specific ions or molecules across the membrane. So in conclusion, selective permeability is just like a bouncer. It lets things like oxygen, water, small nonpolar molecules, ions, nutrients go through. It's important to remember that things that pass through because of selective permeability all have different rates of time that it takes for them to pass. The specific substances that can pass through the membrane depend on the type of cell and its environment. Thanks for watching. If you have any questions, leave them down below. Peace.